and then we can find the error. And this matrix is the inverse of the 4x4 Hilbert matrix. And the number below is error. It is rather small here for this example. And if we increase the size of the Hilbert matrix by 10, so what we need to do is to replace the two numbers here. First, generate a 10 by 10 Hilbert matrix, and then we can find the norm of it, and then so we can find the inverse of it, and we can find the norm of the error matrix. And we may see that the norm increases to 10 to the 4 minus the 4th power. And if we further increase the size of the matrix, we may find that the error might be very large. If we change the size to 20 by 20, then we may see that the error is quite large for this matrix. So in this case, the matrix we obtained is not the real inverse, of the matrix. And also you will get a prompt like this to say that the result may be inaccurate. So let's try a symbolic way to find the inverse of the matrix. If we get a 20 by 20 Hilbert matrix, and here we should not use the norm function again, because that norm function can only be used for double precision matrices, not for symbolic matrices. So we just need to perform the validation here by checking the error matrix itself rather than the norm. By using the symbolic method, we can easily find the inverse matrix of H like this. And the following is the error matrix. It is a zero matrix, so there isn't any error. So we say that H1 is the inverse matrix of H. And if we further increase the size of the matrix, if we are using symbolic computation, what we can get is the exact result. And you may see that the numbers of the inverse matrix might be very long. And if you are using the double precision algorithm, you will reserve kind of results like this and omit the rest of it. So in double precision, we cannot find the accurate result for some certain matrices. And if you are using the symbolic computation, you will get the accurate result. So this is the first example. Let's consider the other example. We know that this matrix that we have used it before, the determinant of this matrix is 0. So it should be a singular matrix. So let's try to find through Matlab what is the inverse matrix of such a matrix. If we want to solve this problem, we need to give a command like this. First enter the matrix into Matlab environment, and then code A and B function. And then we can validate it by multiplying A and B together and see what they are. have 3 steps in the computation. First, to enter the matrix, then call the AND function, and then validate it. We can enter the matrix with no problem. However, when we call the AND function, we will be given a prompt, a warning prompt like this, which means that the result may be inaccurate. And this matrix is close to a singular matrix. And in fact, it is a singular matrix. Now we can find the value of A times B, and in fact we are expecting to have an identity matrix, but we can only have the result like this. It is not an identity matrix, so there might be error. And also we can find that the values of the inverse matrix, the so-called inverse matrix, this is not correct and have a very large value in the component of the matrix. So this is a numerical method. We have a prompt that the result may be inaccurate, but we can find something. If we are trying to solve the problem, by symbolic method, that means we first have to convert the matrix into a symbolic matrix, and then take the inverse. What we obtain is an error message, saying that the matrix itself is a singular matrix. So there isn't any inverse matrix exists. This is the correct form in mathematics. So the third example for inverse matrix. Suppose we have Hankel matrix. What is the inverse matrix for it? And how to verify whether it is correct or not. To generate the Hankel matrix, what we need to do is to first declare that A1 through A4 are symbolic variables, and then call the Hankel function to construct H matrix, and then take the inverse of it. And finally, we can find the inverse matrix of it. Like this. This is the first column of the inverse matrix, second column, third and fourth column of the matrix. And we can validate it by command like this. Answer is the result from this command. So it is supposed to be the inverse of the matrix. And it seems that the error is not 0. So what we need to do is to simplify the result. And finally, it is not identity matrix, but we can simplify it and find that it is an identity matrix. So the inverse matrix we obtained is correct. This means that the function INV can also be used for symbolic matrix with variables. For this kind of matrix, we can also find the inverse of the original matrix. Should we have a break? Yeah. For the norm,